Okay, today is the last day of review for the Chapter 15 test, which is on inverse trig. And here are some little restrictions. Inverse sine is only allowed in these two quadrants, quadrant 1 and 4. Inverse cosine was only allowed in quadrants 1 and 2. And this one, inverse tangent, is only allowed here. And why is it so far from that line? Because it can't touch pi over 2, or what's this one down here? That is not 3 pi over 2. In inverse trig world, it's negative pi over 2. That's a really important point. Because in inverse trig, your answers, when they're down in here, are negative angles. Okay, so let's say I got done with this, and I had an answer that was like the 1, 2 root 3 triangle. Then I'd be tempted to say it was a 30-degree angle, but then I go, oh, it's got to be radians. So that's pi over 6. But you can't say it's all the way around to here because that answer is too big. The answers are only allowed to be between pi over 2 and negative pi over 2 if you're talking about tangent or sine. And so again, this answer, you would say negative pi over 6. All right, that was just an example of when that negative thing matters. Okay. So now, could you shut that door for us, please? Thank you. So, to actually answer this question, inverse cosine of negative a half, it's like cosine of theta equals negative a half, except it's got extra restrictions. Because it's inverse cosine, it can't be here and it can't be here. And because cosine is negative, and all things are positive right there, right? Then it can't be there because that would be saying that cosine was positive if I was over here. All right, so now I'm drawing it here. Cosine is adjacent. Hypotenuse. Root 3 is here. What's across from the root 3? That is a pi over 3, also known as a 60. But pi over 3 is really over here, so that is not pi over 3. It is a whole bunch of pi over 3s. To be specific, 2 pi over 3 is this spot right there. That's the angle. Why were we getting an angle? Because that's what inverse problems are asking for. They already gave me the sides. They want an angle. Looks like that. Cosine of that angle. Any questions? Okay. That, just think about it. I just said that. I was about to say that was an easy one. Just think about all the things you had to know to be able to make that work, and yet that's an easy one. That's why this stuff is tough. Because even an easy one, you have to know like 6 different realms of knowledge. You got to know where things are positive and negative, different functions, where inverse functions are even allowed. You have to know how to rewrite this as a more traditional looking trig equation. You have to know where to draw the triangles. You have to recognize a triangle as a 30, 60, 90 triangle. You have to know that within the 30, 60, 90, it's not just 30, it's also radians. You have to know that it's a bunch of radians, not just one. So yeah, these are complicated. So if you feel like this has been hard, it should be. All right, so let's move to one that's really, really close to this. I'm just going to, in fact, take the same exact question and add something to it. What if I said instead of the original problem being this, what if I put a secant in front of it? Secant of that. So you don't have to redraw the whole thing. I'm just asking you to change the original problem to be secant of what we just did. Secant. I've actually encouraged you not to use secant, so you instead figure out the what of it, the cosine of it, and then flip it. Cosine of it, I know, cosine of it is negative 1 over 2, and then I just have to flip it, and that makes it negative 2 over 1. Now, I know some kids are going to say, oh, so you just have to flip this. Nope. Let me give you an example of one where you wouldn't just flip it. Secant of cosine of, for example. So some kids that want to take a shortcut and just go, oh, so I just have to flip that over. It's 1/2. Nope. Now why? First of all, always do the problems from the inside out. And if I had to do this problem, my first step would be writing this. And I hope this would make you pause for a moment and say, how the heck can cosine, which is adjacent over hypotenuse, how could the hypotenuse be half as big as the adjacent side? Is that even possible? No, so there's no solution. Another way to think of it is the cosine of this, cosine is a wave, right? And it goes like this, and it keeps going forever. And cosine is expected to be 2. What's the highest cosine ever gets? 1. So cosine can't be 2. So there's no solution on that one. So my point is, for a lot of the kids who thought, well, I'll just always take this and flip it. Nope, you shouldn't do that. You got to do the problem from the inside out, draw the picture of it, and then in this case, you'd realize, oh, no solution. All right. Let's move on. Another type of question is where they are factored. This is not an inverse trig question. Therefore, it does not have all those restrictions. Therefore, generally, you get more answers. See if you can solve. Oh, question? This is cosine. Cosine of theta plus 1 and sine theta. And they're being multiplied, and it equals 0. The hint is both of these have to equal 0, so you get a whole bunch of different answers. I'll pause for a moment while you try that one. So, on this problem, we have set them both equal to 0, and now I need to solve. This one is nice and clean, but it's not a triangle. You can't make a triangle for this one, because if you put it over 1, like I usually suggest, so you get 2 sides, you realize that you have adjacent and hypotenuse being equal, which doesn't happen in a right triangle. So we got to make a quadrantal for it. Sine's y, cosine is x. So you got to know that x equals -1 is what you're really looking for. Where is x equal to -1? Well, this is the x direction. So where is x -1? It's right there. And where is that spot? That's pi. If I wanted to be really sure, I'd say what on the unit circle would be right there? -1 comma 0. And cosine is the x. Something's wrong. No, x, this is the x. My bad. Okay, so the x is -1, so that's the right spot. Good, I checked myself. It's pi. Raise your hand if you had pi as one of your answers. Okay, good. Then the other one is sine equals 0. I'm going to make a new one for this one. Sine is y. Where is y equal to 0? Here's the y. Y is equal to 0 right here, but there's no dots there. It's here, over here. And that puts us at -1, 0, and 1, 0. And my final answer then is, where is y 0? Here and here, which is at pi and 0. We already had pi as one of our answers. So I'm going to look and 0. Now, what if I had said, find all the solutions? What would you do at this point? Plus 2 pi k. What if I'd have said, I want all the solutions between 0 and 2 pi? This would be it. Yes?
Could you have said pi and 2 pi, or just 0 and pi?
Good question. 0 and 2 pi are synonymous, so I would have accepted both. The only way you could get burned on that is if they said that theta was between 0 and 2 pi, and sometimes you see it written this way, where it can be 0 and it can't be 2 pi. The logic there is, it's encouraging kids to use the simpler answer, and 0 is simpler than 2 pi is. Okay? Yes? It will specify. If it doesn't specify, you should say, this doesn't specify, and then I'll tell everybody, I want all solutions, or I want the solutions between 0 and 2 pi. All right, so that one was already pre-factored for you. Do you get that we could make it harder by making it not factored yet, and you have to factor it? All right, so let's try one like that. So, 2 sine squared of theta plus sine of theta equals 1. You do just a little bit of work to get this thing set up, then you can factor it, and then you can get multiple answers. Why does this look different than the last one? Well, because it isn't equal to 0 yet. Start with that. Okay, so we're going to factor this thing. What did you think it factored to? And if I had to be sure you were right, I could double check you by doing firsts would give me 2 sine squared. Outside and inside should give me sine theta, which it does. And the lasts, which should give me -1. All right, cool. I know you did it right. Now I'm gonna go pretty fast here because this is a lot like the one we just did, and I don't think you need a lot of review on that. This one comes out to sine theta equals 1/2. Now, for once I set it equal to 0 and then solve. This one is sine theta equals -1. Where is y -1? It's right there. That is 3 pi over 2. If this had been inverse trig, what would have been called instead? -pi over 2, if it was inverse trig. But it's not. So it's 3 pi over 2. And then this other one, sine, is positive. It means it's got to be here and here, not there and there. And that means this one's pi over 6, and this one is a bunch of pi over 6s, specifically 5 pi over 6. So pi over 6, 5 pi over 6, and 3 pi over 2. Who would have had that one right? Okay, good. Now, the last and most complicated practice problem here. And that is where you have a complicated angle. Now, I personally wouldn't solve it that way. I would change this right away to what? A u. And you let u equal that. You solve it, then you go back and substitute that complicated stuff back in for the u. And this does get complicated, all right? But at least 3/4 of last hour figured it out, so let's see if you can do it. I'll pause for a second while I give that a shot. Okay, let's see if you did it right. First off, I suggested you let u equal the 3 theta minus pi over 4 so that your life will be easier. Now I'm going to make sine be positive. All students take calc. Sine is positive in the top part. Opposite hypotenuse, 1 root 2. Cool, I know that one. There we go. There's the two spots, and they are pi over 4 and this other spot right here, which is not pi over 4. It's a bunch of pi over 4s to get there. It is 3 pi over 4. But wait, there's quite a bit more. Plus 2 pi k. Now, pretty much always in a problem like this, you are asked to find all the solutions or all the solutions between 0 and 2 pi. Either way, you'd want to do this part. And then, we now know that u equals that, and u equals this. But you aren't done if you have a u in your answer, because that's a hint that you have to substitute something else back in at the end. U is actually that. So it's 3 theta minus pi over 4 here and here. Then you add pi over 4 to both sides, and you end up with 3 theta equals 2 pi over 4, which is the same as pi over 2, plus 2 pi k. And then 3 theta equals, I'm adding pi over 4 to both sides here now, and I get 4 pi over 4, also known as pi, plus 2 pi k. Then I have to multiply everything by 1/3. And here's my answer. 2 pi over 12, which could be reduced to pi over 6, plus 2 pi k over 3, and pi over 3, plus 2 pi k over 3. How many of you are able to go all the way, beginning to end on that? Awesome. Now, you had to know so much trig to be able to pull that off. That's impressive. Now, I want you to just ponder for a moment. That's all the solutions. What if I only asked for the first 6 solutions? Well, what were the first two solutions was this one and this one. What would the next solution be? If you put in k equals 0 here, that's not going to do anything, right? But if I put in 1, then I'd get the next two solutions. What if I put in 2? Then I'd get 2 more solutions, right? Okay, so that's a question they could ask is, what are the first 6 positive solutions? Another thing they could ask is, what are all the solutions that are less than 2 pi? You might be tempted to think that that's just these two, but since we're only adding 2 pi over 3 when we stick a 1 in there, it's very possible that one of those, even after you've added 2 pi over 3, could stay less than 2 pi. So you could end up with just a shorter list than all the solutions. All right. Sir?
So if you want the 3 solutions, you'd have to add...
Well, first, let's write down the 2 solutions that we have in the beginning. That would be, just wait, that would be pi over 6 and pi over 3. Would you agree that that is 2 of our solutions? Okay. So then you'd add 2 pi.
So then you add like another 2 pi k if you want to...
Plus 2 pi over 3. K is going to just be 1, otherwise we don't want a k in there, right? And we'd add plus 2 pi over 3 to this. Now we'd have a total of 4 solutions. Yeah, you'd have to get a common denominator and stuff. Okay, let me just show you that quick. So that times by 2 times by 2, and this I'm going to times by 2. No, actually I don't need a common denominator there. I already had one. So that is going to be 3 pi over 3, which is just pi. Is that less than 2 pi? Yeah, so that would qualify in the whole answers that are less than 2 pi thing. And then this one, which would be 4 pi over 6 plus 1 pi over 6 makes 5 pi over 6. So now I've got 1, 2, 3, 4 answers, and they're all smaller than pi even. You know what I'm saying? So then couldn't I add another 1 to my k and make something else instead of adding 2 pi over 3? I can put a 2 in there and make it 4 pi over 3. Put a 4 pi over 3 here, and then I could get even more solutions. So anyway, I know it's stretching some of you beyond where you're comfortable, but at a minimum, almost everybody had it before when it was plus 2 pi k over 3. I just want to stretch you to think about that k could be 0, in which case it's like you didn't even add it, or 1, or a 2, or a 3, and you keep getting more and more answers in case they want more answers, but not infinite answers. Okay, so your homework for tonight is to just study for the test. I recommend doing old problems. A problem you did a week ago, since it's such abstract stuff, you probably aren't going to remember. You could just do it again, or take ones we skipped. That's all I got for you for today. Test is tomorrow.